Hello, 8th standard children. Hope you all are cool as the weather outside. Today is a special day for at least few 8th standard children. What is so special about this day? There is something special. Few 8th standard children will be celebrating their birthdays today, no doubt about it. Birthdays are really special days, isn't it, my dear children? Yes. That is the day we were born. That is the day we stepped into this world for the first time. That is the day we had a first glimpse of our parents. So naturally, undoubtedly, birthdays are really special. You have to enjoy on that day, rejoice, make it a memorable one with your near and dear ones. So I take this opportunity to wish all the children who are celebrating their birthdays today. Wish you all a very, very happy birthday, my dear children. Many, many happy returns of the day. I also don't like to miss those children who celebrated their birthdays last week. For them, belated birthday wishes. And for those children who are celebrating their birthdays in the coming weeks, for them, advance birthday wishes. So I hope you all are now acquainted with chemistry topics about matter. What did I teach you in the last class? It was about matter is made up of tiny particles. So I wish to continue from where I stopped. Now before that, I would like to ask you all a question. Are you all happy, my dear children? Especially during these days. Are you really happy? You can ask this question to your mind. Human beings, do they have the same emotions throughout the day or throughout the life? Can we be all happy throughout? We are normal human beings. We tend to become sad, isn't it? So we also go through different human emotions. For example, just to give you an idea of what I am going to teach you today, just a simple way of my illustration, hope you like it, okay? Now just suppose that you are sad today because your parents scolded you, or maybe your teachers when you were in the class, they scolded you. You will tend to be sad, isn't it? Yeah, you will become sad. But when you realize that they scolded you only for your good, for your well-being, you naturally become happy. The moment you realize that നമ്മളുടെ നല്ലതിന് വേണ്ടിയിട്ടാണ്, so you become happy. So first you were sad, you became happy, isn't it? First you were sad, now you became happy. Now sometimes we become angry also. Now if you ask for something, if you demand something, and if your parents refuse, of course we get angry. But do you remain angry throughout the day? No. One smile can change everything. You will become happy. So human emotions keep on changing. You were angry, you again became happy. But I would like to tell you something, children. As a teacher, it's my duty to tell you, without saying that I can't move on, anger is the root cause of all the evil. Whatever you see in the society, to an extent, it is because of our inability to control our anger. See, somebody else is creating a mistake. We are getting angry. We are ruining our body. Dangerous chemicals and toxins are released in our body. Our metabolism is disturbed when we become angry. It is somebody else's mistake and our body is ruined. So next time when you become angry, please think that no, I will not be angry, because if I become angry, my body metabolism will be disturbed. I have to take care of my body, isn't it? So don't be angry. Of course, there are occasions where we become angry, but immediately we have to revert back to happiness. Revert to the state of happiness. Clear, children? So as human emotions keep on changing, there is one thing that can change our emotions and we come back to happiness. What is that thing that we have? We have something full of power, potential. Our mind. Our mind has immense power, isn't it? If I decide I will be happy, I will remain happy. If my mind says be sad, I will be sad. So we have to train our mind in such a way that we will be happy always. Now how can you train your mind? For that we do meditation in school. Now you are at home, please practice meditation even when you are there. Surround yourself with positivity. Always positive people, positive books, whatever positive learnings. That will naturally make you all happy. Clear? So our mind is the deciding factor. See, if our mind wishes you, if you decide, your mind can think that you are talking to Lionel Messi. You know who it is, who he is, isn't it? You can feel that you are taking an autograph from Ronaldo, Cristiano Ronaldo, or maybe you are shaking hands with Neymar. See, we also follow football, okay? Teachers also know about football. So, in a second, fraction of a second, our mind can jump, traverse long distances. So, be happy always. That is what I would like to convey in this class to all of you. Clear? So, why I have been telling you all this? Because today my topic is also related to the change of state. Just as we move from sadness to happiness to anger and again coming back to happiness, matter also has three states: solids, liquids and gases. They also can change their state if they wish. What is the factor that can change them? Listen to me carefully. Okay? So today's first topic is change of state. Look at the board. You are learning this for the first time. Now this is solid state. Okay. When I heat a solid, see I have written heated. What do I get? When I heat a solid, I will get the liquid. Don't worry, I will explain to you. This is there in your textbook. Okay. So when a solid is heated, see the arrow is pointed towards liquid. So when solid is heated, it changes into a liquid. Now, liquid also changes to gas. How a liquid can change to gas? Again, when it is heated. So, when a solid is heated, it changes to liquid. When a liquid is heated, it changes to gas. You know what is heated, right? Chudakku. ഒരു സോളിഡിനെ ചൂടാക്കുമ്പോൾ അത് ലിക്വിഡ് ആവും, ലിക്വിഡിനെ ചൂടാക്കുമ്പോൾ അത് ഗ്യാസ് ആവും. Now vice versa. നമുക്ക് റിവേഴ്സ് ഗിയർ ഇട്ട് നോക്കാം. ഓക്കെ, റിവേഴ്സ് ഗിയർ ഇടുമ്പോൾ that means ചൂട് കുറച്ചാൽ, ചൂട് കുറയ്ക്കുക means we are cooling it. So when gas is cooled, it again becomes liquid. Now for liquid to become solid, what we have to do again? We have to cool it. Clear? Is this clear, children? Don't worry, I'll explain. So when solids are heated, it turns to liquids. When liquids are heated, it turns to gases. And reverse order, if gases are cooled, it becomes liquid. And if liquids are cooled, it becomes solid. Now there is a classic example to prove this. I have written it down. You know ice cubes. Now suppose I am holding ice cubes in my hand. Now because of the body heat and the heat of the surroundings, this ice will change into what? Water. Ice പുറത്ത് വെച്ചാൽ അത് എന്തായി മാറും തന്നെ, നമ്മളൊന്നും ചെയ്യണ്ട, it will turn into water. How can I now change ice to water within 3 seconds? Just look. See here, ice changing to water. The arrow is pointing towards water. That means ice has now changed to water. When I heated ice, it turned to water. Ice is a solid. When I heated it, it became water. That is a liquid. Now again, if I wish to change water to water vapor, what should I do? I will heat. വെള്ളം പാത്രത്തിൽ വെച്ചിട്ട് ഗ്യാസ് ഓൺ ചെയ്താൽ you might have seen the water vapor or the steam coming out through the vessel. All of you might have seen, isn't it? So solid changes to liquid, liquid again changes to gas on heating. This is a classic example for the change of state. The state here was solid. Now it has changed to liquid state. Water like, now again I am heating this water. It will turn to water vapor or steam. So when I heated it, okay. Now, can I change this water vapor to water vapor? Yes. What should I do? See, draw a line and point it towards water. That means water vapor has now changed to water. See here, pointing. So I write here cool. Cool it. Now again this water changes to ice. If a glass of water, if you take one glass of water and keep it inside the freezer. You know what is freezer? Fridge. Inside the fridge there is a top portion freezer. If you take one glass of water and keep it inside the freezer, it will naturally turn into ice. So water on cooling, it turns to ice, that is a solid. Now you understood the change of state. This topic, is it clear? Once again, solids changes to liquid on heating, liquid changes to gas again on heating. And if I wish to bring gas to liquid state, I can cool it. If I wish to bring the liquid state to solid state again, I can cool it. So this is about change of state. I hope this is clear. If you have any doubts, you can call me. Okay? So, 3 states of matter can be changed by which form of energy? I ask you a question. It is there in your textbook. Which form of energy is responsible for the change of state? Which is the energy that is responsible? Heat. So, heat is the energy which is responsible for the change of state. Clear? Chudakumbo, states are changed. And when we decrease the temperature, decrease the heat, that is cooling, again the states are changed. Is this clear? I hope it is now clear. Can I move on? Now before that, you can have a look at the picture depicting the same thing. It is there in the textbook. You have to write this in your file. Please note it down. This example also is very, very important. Write this in your file. Now the next point. Next, as I move on down towards the page down, there is this picture. Observe the picture. The same picture that is there in your textbook, I have drawn it on the board. This is a representation of 3 states. Do you remember in my previous class, one of my classes, I asked you, why water is a liquid? Why this chalk is a solid? Now you will get the answers. So be attentive. Now this is a representation of a solid state. I told you matter is made up of tiny particles. These are particles of solid, any solid that you can imagine. You can take ice for example. Ice is a solid. Now the particles in a solid will be in this manner. Of course, the directions are shown in the textbook. This is representing the particles in the solid state. This figure is representing the particles in the liquid state. For example, in water, the particles will be in this form. Clear? And in steam or water vapor, the particles will be in this form. So this figure is very, very important. You have to draw it in your file. Based on this, questions are asked every year. You shouldn't forget this diagram, children, for a long time. You should remember this. This is a representation of the 3 states of matter, the particles, how they are arranged. This is the arrangement of particles inside a solid, inside a liquid and inside a gas. Clear? Okay. Now, so as I told you, this is the representation of the particles in 3 different states. So this figure you have to draw it in your file. It is very important. Questions are asked always on this topic. Now, when I told you when a solid is heated, it changes to liquid. When liquid is heated, it changes to gas. So when heat energy energy is absorbed or when heat energy is reduced, changes will occur in these three states related to four properties. Four properties will change when heat is either absorbed or heat is given out. When solid is heated and when liquids are cooled, okay, properties will change. Now what are those four properties that we have to study related to this figure? First one is distance between the particles. I told you these are particles, so we have to study what is happening to the distance between the particles. Then when heat is gained or lost, what will happen to the movement of the particles? I will tell you in detail. Then we have to study what will happen to the energy of the particles in the three states. Then about attraction between the particles. So I will teach you one by one. Each property I will be giving you a detailed explanation. This you are learning for the first time. So you have to be really very attentive to my class. Is it clear? So this is a representation of the particles. Now first is distance between the particles. Now when heat energy is absorbed by solid, when we heat a solid, it changes to liquid, that you know. Clear? Now these are particles. These are particles in a solid and these are particles in a liquid. What is the meaning of the word distance? Distance means duram. So can you see here solid particles and the liquid particles? When solid changed to liquid, what happened to the distance? Here they are very close, but here the distance has increased. Duram koodiyide. When solid changes to liquid, the distance between the particles increases. Okay. Again next thing. When we heat a liquid, it changes to gas. So what has happened to the distance? First the distance was this much. Now it has become this much. Widened. The distance has increased. Again, when liquid changes to gas, the distance increases. Understood? Solid changing to liquid, the distance increases. When liquid changes to gas, the liquid has again increased. Now when I cool this gas, what will happen? It will turn to liquid, that you know. I taught you earlier, isn't it? So when gas is cold, it changes to liquid. What is happening to the distance? Now think and then try to tell the answer to yourself. What will happen? See here, gas, the distance was this much. When gas is turning to liquid, the distance has decreased. So when gas turns to liquid, the distance decreases. Again, when liquid changes to solid, see here the distance was this much between particles. Here there is no distance at all, they are very close. So when liquid changes to solid, the distance again decreases. Clear? Understood? Again I tell you, when the solid is heated, it changes to liquid. The distance between the particles increases. You can see when liquid changes to gas, the distance increases. Now reverse order. When gas changes to liquid, the distance decreases. When liquid changes to solid, again the distance decreases. Increase karna pura. Decrease means karna. Is this clear? So when heat is absorbed, what has happened? The distance decreases. The distance increases when solid changes to liquid. Clear? When liquid changes to gas also, the distance increases. But when gas turns to liquid and liquid turns to solid, the distance decreases. Don't get confused. Is this clear? Now can I move on to the next property? Which is the next property? movement of particles. Movement means what? Moving. You know what is moving? That is moving. So what will happen to the movement? How, when a solid changes to liquid, what will be the difference in their movement? Let's have a look. Okay. So the second property is movement of particles. Now here the particles are very close, but when it changes to liquid, they have gone a bit far. Movement has increased, isn't it? Yes. So in the case of the second property also, movement of particles. You don't confuse yourself. Now I am coming to the second one, movement of particles. Particles are very close in solid. Now they have moved a bit, so movement is increased. Now when liquid changes to gas, again the movement has increased. Gas particles have gone away, isn't it? Very far. So in liquid state the movement is higher than that of a solid. But in gaseous state, the particle states can move anywhere. They are free to move. So movement is higher in which state? Movement is higher in gaseous state. In gas, the particles can move freely. It is high, but very, very less in solid. Is this clear, my dear children? Movement goes on increasing from solid to liquid to gas. But when it comes in the reverse order, the slope, gas they can go anywhere. But when it is cooled and when it is changed to a liquid, the movement, what happens? Decreases. So they have come a little closer. And when liquid changes to solid, again the movement has become less. They are very close, unable to move, very limited movement. So solid has limited movement, gas has very high movement. Is it clear? So first property was distance between the particles. Distance പറഞ്ഞാൽ ദൂരം. Solid നിന്ന് liquid നിന്ന് gas പോകുമ്പോൾ distance will increase. And in this order it will increase from gas to liquid to solid. Clear? Second property was movement of particles. Movement was limited in case of solid because the particles are not able to move. But in gas, the movement of particles is very high. Clear? In liquid state, it will be between solid and gas. Intermediate form. Clear? Is this clear? Now I will go to the third property. That is energy of particles. Energy of particles. What is energy? Are you all energetic? If you eat food, automatically you will become energetic. So have food, okay, properly. Adequate amount you have to consume food. So here related to this property, listen carefully. Now energy of particles. Now to give you a better idea, suppose we are sick, we have fever, suppose we have fever. We are confined to our bed. We are not able to move. Doctor has prescribed medicines. So in that case, unable to move, our energy will be very less, isn't it? You take medicines. After 3 to 4 days, you come to school. So first, you are in this position, confined. Then you are able to move when you come to school. You are able to move around in your classroom. That means your energy has increased a bit. First you are on bed. Then when you are in the classroom, when you see your friends, your teachers, your energy increases a bit, isn't it? Then after 5 to 6 days, what happens? During PT periods, we can see you all playing football or some other games on the ground. Why? Because your energy level is very high. Understood? Similarly, in the case of solid, the particles have less energy. And when it is changing to liquid on heating, heat cheyidal solid liquid energy endai it increases. Energy from solid to liquid it increases. from liquid to gas, I told you, first you were in the classroom, then in the meeting period full of energy. Similarly, liquid state has less energy compared to the gaseous state. Gas has high energy, so they are able to go anywhere. Oxygen can go anywhere. You can't say oxygen to stay in the same room where you are. No, it will not obey. It will go to different rooms, different places. Oxygen is there everywhere. Why? Because it is a gas. Now you understood why oxygen is a gas and why water is a liquid and why this chalk is a solid. You will get an idea afterwards. One more property is remaining. So energy is very high in which state? Gaseous state. Energy is very less in solid state. So when we heat a solid and when it changes to liquid, energy increases. Liquid to gas, energy increases. Reverse order. Gas to liquid, when gas is cooled, it changes to liquid, energy decreases. See, we have come close, energy is decreased. And when liquid changes to solid or cooling, energy is again becoming less. Coming together, unable to move, they have become lazy. Energy is less. Got an idea? Okay. Now the fourth property. Which is the fourth property? First was distance between particles. You know the order. Second was movement of particles. Third one was energy of the particles. Clear? So if this figure is there in your mind, you will be able to answer all the questions. So this figure should be there in your mind. It should be written in the file. Again I am telling you this. Attraction between particles. Attraction between particles. Which particles? Particles in solid, liquid and gaseous. What is the meaning of the word attraction? Now suppose I like a flower. That means I am getting attracted towards that flower. Attraction means bonding, a force that is holding together the particles. Okay, so I'll tell you something so that you can understand it much better. Now suppose this is your young age when you are in LP, UP classes. You are more attached to your family, isn't it? You spend a lot of time with your parents, your grandparents. You spend quality time with them. Attachment or the bonding is stronger when you are in LP, UP. Then when you reach HS and higher secondary classes, what happens? College level. What happens? You spend less time with your family because you go to colleges and schools for study. You get more friends, you happen to spend more time on mobiles. Attachment with the family is there, no doubt, but it becomes a bit less because you have to spend time with your friends over there, with your classmates. Clear? Now we got an idea. Here the attachment was stronger, here it has become less. Then when you go to pursue higher studies or in the search of jobs to different states or different countries, you will be detached from your family. You should not be. You should be attached to your family because the roots are always here, our family. Don't be detached. But of course we have to go leave our family and go for the sake of job. That is also very important. So what I am trying to tell you is, in the solid state, the bonds are really very strong. They are very close, the particles. Did you see this? Attraction is higher in the solid state. When I heat the solid, it changes to liquid. What has happened to the attraction? The bond has become slightly weaker. So, attraction is less. They are ready to move a bit. Attraction becomes less, decreases. When solid changes to liquid, attraction decreases. You can see it. The bond has become a bit weaker, so they will move a bit farther, and so attraction has decreased. Now when liquid changes to gas on heating, it is clear. See, one particle is over here, other particle is over here. Bond is very, very weak. Attraction also very, very less, and they are able to move freely when liquid changes to gas, again attraction decreases. Attraction is decreased, so gas can move anywhere. So we can see oxygen, hydrogen, they can move anywhere because it's a gas. Attraction between the particles is less. Clear? Again, when gas changes to liquid, what happens when it is cooled, when gas is cooled? See here it is clear. Now the distance was this much. Bond is weak, but now they have come together, closer together. They have come closer together, so attraction is slightly higher than this gas. So when gas changes to liquid, what happens? Attraction increases. Don't get confused between this increase and decrease. Think and write. Take a minute, think and then write, okay? Liquid changes to solid. What happens? See here, the particles are very close. The bond has again become stronger. So this is a solid state. Attraction is very high between the particles. See here, very close. So in the case of solids, we have a permanent shape because they are very close, compact. So when liquid changes to solid, again attraction increases. Understood? In our case, once we go for higher studies and jobs, we are slightly detached. We just give a call to our parents, but never forget about our parents. Think about them, the sacrifices they have made for you all. Okay? I just gave you an idea so that you will understand better, that's all. But this is about particles. Now, first one was distance between the particles. You know it, when solid changes to liquid, liquid to gas, distance increases. And in the reverse order, it decreases. Movement also, the same. Energy also the same. Solid to liquid, liquid to gas, energy increases. But in the reverse order, energy decreases. Energy is maximum here, energy is very less, minimum in solid. Okay? And the last one, attraction between the particles. When solid changes to liquid, attraction decreases. So it has become a liquid. Now you understand why water is a liquid, because attraction has become less. So if we spill water, it can only flow to a certain extent. But gas, attraction is very less, bonding is less. The force that is holding the particle is very less, so it can move anywhere. And in the reverse order, gas to liquid, attraction increases, liquid to solid, attraction again increases. So I think I will stop here. I hope you are not confused with the word increases and decreases. Increases കൂടുക, decreases means കുറയും. Clear? So always, whatever you have studied, try to recollect. You are learning all this for the first time, and you are free to call me, children. I know you may have doubts. You can call me. I will help you. Okay. So whatever I have taught you today, first one was change of state. The figure is there in your book. You will have to write it in the file. Second one was a classic example of ice turning to water, water turning to water vapor. Then this figure is very, very important. Solid, liquid, gas, and the four properties that I taught you. What happens to the particles? What happens to the distance? What happens to the movement? The next class I will tell you about the table related to this. You have to do it on your own in the next class. Okay, so I think it's time.